In this video, we will be talking about percentages. Now, a percent is talking about anything out of 100. The symbol for percent looks like this. I see that as two zeros with a line. Well, it sort of looks like a fraction to me. And in fact, the way that you replace a percent sign is by writing whatever the percent is over 100, and then the sign goes away. Okay, so percentage means something over 100. So if I had, let's say, 20%, if I wanted to write that as a fraction, I would do 20 over 100. And again, by putting it over 100, it cancels out that percent sign. Now, if I had, let's say, 5 7/7%, which is not a pretty decimal, right? Not a whole number decimal, you would still take the value, the 5 7/10, and put it over 100. And then we would have strategies that we've used before, right, for turning that into a fraction with integers. Now, the same is true if you have a fractional percent. Let's say we had 2/3 of a percent. We do the same thing. In order to replace that percent, we would have to take that whole fraction and divide it by 100. And we'll be going into lots of examples of these because this process of converting a fractional percent to a fraction is one of the trickier that we're going to be doing. But that said, I'm just trying to illustrate that it doesn't matter the format of the number of your percent, it still goes over 100. So this one would become 2/3 divided by 100. And then you would follow the process for division with fractions, okay? So from that, anytime you are getting rid of a percent, you have to take what the percentage is and put it over 100. All right, so looking at number 1, it says write each percentage as a decimal. All right, so the first step that we're going to do is go ahead and replace that percent sign again by putting, in this case, the 37 over 100. Now, anytime you divide by 100, it moves your decimal to the left twice. So we start with 37, our decimal is here, and we move over twice. So that means the decimal equivalent of 37% is 37 hundredths. This step right here, you may feel like, oh, I don't need to do that. However, people frequently make a mistake when they have a single digit percent and end up putting the decimal in the wrong place. So every time you convert these, make sure you do that step of actually showing where that decimal moves. And I'll show you in B why that's so important. All right, so again, I'm going to write this as 5 over 100 to get rid of that percent sign. Now I'm going to write the 5. Decimal is right here, and again, I have to move it over twice. So I have a 0 there. That 0 gets dropped if people rush through single-digit percentage conversions, and they often will end up, like in this case, I've seen a lot of students give me 0.5. So make sure to actually do that step of showing the movement of the decimal, and it will protect you from accidentally dropping that second 0. All right, now go ahead and try C and D, where you rewrite the number over 100, and then go ahead and show that decimal movement so that you can see where the decimal lands. Okay, so for this one, we've got 3 digits in our percent. So we have 129%, which is 129 over 100. So I'm going to rewrite my 129, and then my decimal starts to the right, and it moves over twice. So my final answer is 1 29 hundredths. Now, once you are consistently doing these correctly, it is not necessary that you show the fraction. So for D, I'm going to show you what I mean by that. So instead of showing the 357 over 100, I'm just going to jump to the decimal movement. So I know because I'm dividing by 100, to get rid of that percent, I have to move the decimal twice. And I get 3 57/100. So that way is absolutely fine. At the same time, I wouldn't do that early on. I would continue showing the fraction and then showing that decimal movement. Once you're consistently getting it right, jumping to what I just showed in D is absolutely fine. So for 2, the instruction here is to write each percentage as a fully reduced fraction with integers. So fully reduced fraction with integers. So basically that's saying the fraction cannot have decimals in it, right? That's the quick way of thinking about that. We are once again needing to get rid of our percent sign. So as before, the first step is to write 39 2/10 over 100. Now, instead of converting this to a decimal, we are creating a fully reduced fraction with integers. Notice we have a decimal in the numerator. That means we have to follow that process that we've talked about before for getting rid of decimals. And that is, what do you multiply by to turn both the numerator and the denominator into whole numbers? Well, we've got 39 2/10 in the numerator. I need to move my decimal once to the right, so I need to multiply by 10. Since I multiply the top by 10, I have to multiply the bottom by 10. That gives me 392 over 100. So there is my fraction with integers, and now I need to fully reduce that. So I see that an even number goes into both of these. 2 goes into both. And in fact, I think 4 will go into both. So let's try that. Now, if you use 2, that is absolutely fine. Remember, that just means that you'll be doing an additional round or 2 or 3 of factoring. Totally fine. So now I'm going to divide by 4. Whatever I do to the top, I have to do to the bottom. And when I do that, I get 98 over 25. Now, it doesn't say a specific format of integer or of fraction in terms of improper fraction, mixed number, so I can go ahead and leave it like this. But again, this is fully reduced, right? That's what we just did. That was this part right here, fully reduced. And they are integers, so no more decimals. All right, so we're going to go ahead and do the same thing with B. I would encourage you to pause the video and try both B and C, and then turn it back on and watch me go through it. The main thing here that you need to remember are to get rid of a percent sign, you put the value of the percentage over 100. If you have a decimal in that fraction after you've done that, you need to follow the process of turning those into whole numbers, and then you need to fully reduce. Okay, so for B, the first thing I'm going to do is pull that 167 5/10 out and put it over 100. I again have 1 decimal place on the top, so I need to multiply top and bottom by 10. That means I have 1,675 over 1,000. Now looking at that, with that 75 at the end in the numerator, it looks to me like 25 will actually go into everything. So this is another one where if you can figure out the greatest common factor, that is really nice because, fewer steps, fewer chances for mistakes. But if you don't and you do multiple steps, absolutely fine. And notice I said that in the previous one. I want you to go to the factors for these that you think of first. Okay, so whatever that is, as long as there are factors for both, you're absolutely fine. Okay, so I get 67. That was 1,675 divided by 25, and then 1,000 divided by 25 is 40. And I no longer have any common factors. This is another, just a reminder in terms of if you have an improper fraction, you can always rewrite that as a mixed number, and it will help you see whether your fraction is fully reduced or not. All right, so C, same process here, right? We're starting with a decimal and a percent sign. So I have my 5 8/10 over 100. Again, I need to multiply top and bottom by 10, and these happen to be the same because the only decimal places that exist for all three of these is the 10th place. So I just need to multiply by 10 to get them all into whole numbers. So it just happens to all be the same for these guys so far. So I get 58 over 100. Both of those are even numbers, so I'm going to divide by 2. And I get 29 over 50. All right, so for D, we're now going to see, well, if we're not starting with an integer or we're not starting with a whole number, what does it look like? And I introduced this, right, when I was first talking about percentages. And I'm going to show you how you can set it up to show you what we're actually doing, and then we're going to rewrite it since we're actually dealing with division of fractions. And yeah, anyway, it will be a lot easier if we write it in a certain way. So that said, I'm still going to do the same thing because I want this first step to be exactly the same regardless of what type of percentage I'm dealing with. So I have negative 2/9 divided by 100. Well, that looks ugly, right? And we don't want to do ugly. So let's go ahead and rewrite this in a format that's more familiar. So remember, this line right here means division. So we can rewrite this as negative 2/9 divided by 100. So now we're doing division of fractions. That means we need to put a 1 under the whole number. Okay, think for a second, what do we do when we're dividing our fractions? We have to flip the second fraction and turn the division to multiplication. So I get negative 2/9 times 1 over 100. It's now multiplication. So what is the next thing that I do when I'm multiplying? Well, I need to cross cancel. So 2 goes into negative 2 negative 1 time, and 2 goes into 100 50 times. Now I'm ready to multiply across. So negative 1 over 450. This problem type is a great example of how it may look kind of scary, right? Because you have a percent, you have a fraction, but as soon as we can turn it into something that looks familiar, right, which is this right here, if you've got your division of fractions down, you'll hopefully feel okay. If you don't have that process down, it's a great way to see that you still need to go back and review that. So go back to the section, right, in the previous videos, in notes, what have you, and go through the process again for how to divide fractions. All right, so we're going to move to E. And what I'll do is I'll do E, and then I'm going to encourage you to pause your video for F and G, or do it now if you feel ready for E, and then go ahead and watch me do it. Okay, so same thing here. We are rewriting this, right? Negative 3 2/5 over 100. However, there's a restriction when we're dividing fractions. You cannot multiply or divide with a mixed number. So I need to convert what's on the top, right, before I can move to the next step. Another reminder for converting from mixed numbers to improper fractions, you need to write it like this. Notice how I pulled that negative out, because when you're doing your multiplying, so 5 times 3 is 15, plus 2 is 17, the negative is not involved in the calculation. So move that negative out, do your calculation, and then multiply the result by -1 to get the negative back in. So here, This now becomes, let's see, I'll just write it up here. So negative 17 over 5. Okay, so I am going to rewrite this as negative 17 over 5 divided by 100. Put that over 1, right? Because anytime we work with a whole number and a fraction, we want to put that whole number over 1. I flip negative 17 over 5 times, I'm going to just move this over 1 over 100. Woo, sneak that in there, and now I multiply across. I don't see anything that I can cross cancel, so it becomes negative 17 over 500, and that is your final answer. All right, so go ahead and pause the video and try F and G. Like in the previous problems, the first step that we're going to do is write the fraction 7/3 over 100. Now we rewrite it into the more familiar format. So 7/3 divided by 100 over 1. Remember, you always put a 1 under a whole number if you're working with fractions. Now we change the division to multiplication and we flip that second fraction. So our final answer is 7/300. Okay, and then the last one. So let's see, we previously did a mixed number that was in E. We have to convert that to an improper fraction first. So that's what I'm going to do. So 4 times 5 is 20, plus 1 is 21. So I get 21 over 4. So previously I showed you how you could do an intermittent step. And then once you got more comfortable, you could just go straight to, it was creating a, when you're eliminating your percentage sign when converting to decimals, I was showing you creating that fraction and then converting it to a decimal. And then the last example, I just showed how to go straight to a decimal. I'm going to do something similar here in that I'm not going to show the actual line with the 100 underneath. Instead, I'm just going to jump to the divided by 100 over 1, because eventually if you become comfortable with that, you can absolutely do that. You don't have to show that double fraction. 1, it's ugly, right? And it might cause a little bit of stress when you see it. And 2, it's not necessary if you know what you're getting to. Okay, so I flipped that to multiply and flipped the second fraction. So now I multiply and I get 21 over 400. And that is your final answer. We're continuing to work between percentages, fractions, and decimals. And this time, the way that this instruction is written out, it says write each fraction as a decimal and a percentage. You could also be asked to write each fraction as a percent. So it goes straight to converting to a percentage. The process that we're going to do is exactly the same. You always have to convert a fraction to a decimal before you can turn it into a percentage. Step 1, for converting to a decimal, you go ahead and divide that fraction. And I get 0 and 75/100. Once it's a decimal, and we've talked about going from decimals to percentages, we multiply by 100. So we're doing the opposite, right? When we had a whole number and we're converting to a decimal, we would divide by 100. Here, because we're starting at a decimal and going to a percent, we have to do the opposite. We have to multiply by 100. So that gives me 75%. This next one, there are 2 ways that we can do this. We can look at this as an improper fraction, and I'll go ahead and do that, and then I'll also show you how to do it where we don't do the conversion. We've talked about this before when we were talking about converting between mixed numbers and improper fractions, and this is just another context where we encounter that. So I want to make sure you're aware of your choices there. So the first way I'm going to do it is convert to an improper fraction. So 5 times 2 is 10, plus 3 is 13. So I get 13 over 5. Now I need to divide that. So 13 divided by 5, that gives me 2 6/10. Now I need to multiply by 100. And the quick way of doing this is when you multiply by 100, you move that decimal over twice. So my final answer is 260%. If I didn't want to convert to the improper fraction, instead what I could do is pull out the 2, divide the 3/5, so 3 divided by 5, which gives me 6/10. So notice I ended up getting the same thing as I did up here. And now I multiply by 100, and that gives me 260%. So 2 different ways. You pick which way you prefer, and you may switch back and forth. It does not matter. So try C and D. Pause the video, try them, and then go ahead and turn the video back on. So step 1, we divide. 15 divided by 9, so 15 divided by 9 gives me a repeating decimal, right, that just goes on forever. So what I'm going to do is I wrote a lot more decimal places than I needed, right? But I always like having extra ones to make sure that when I round, I get the correct places included, right? So I'm going to multiply by 100. That moves my decimal twice to the right. So 166 point, and I'm going to go ahead and round to the 10th place. And then percentage, right? So I basically put my decimal here, and I had places to the right that I could then see what was going to happen to that 10th place. So that's why it's important to always include places further than what you're going to round to. And finally, for D, I'm going to go ahead and just separate this as the mixed number. So I'm going to do 10, and then I'm going to divide out the 2 divided by 3, and I get, once again, a repeating decimal. I multiply this by 100. So my decimal moves twice, right, and lands right there. So now I have that, and then I'm going to round to the 10th place again. And then because I'm solving for a percent, I have to include a percent in my final answer. And that's an important thing to keep in mind for all of the percent problems that we've been working through. If the question is what percent or find the percent, your answer must include a percentage sign. If I had an answer of, like for B, where the answer was 260%, that is very different than 260. So if you don't include that percent sign in these contexts, your answer would be incorrect. So be very careful about that.